Okay. So, hi everyone. So, thanks for staying so late for the talk. My name is Leandro, and I work at ARM as a DevOps engineer. One of the main things we do is basically support the compiler teams and tool chains in general on building CI testing and benchmark with actual hardware. I'm also a contributor for LNT, which is a performance tracking tool for the LLVM. And the idea for today is to give you one more tool for your toolbox when investigating issues with the compiler or the toolchain in general. So basically, when we are investigating some issue or the toolchain is playing up, Clang is crashing or something, or any tool is crashing, one key information when investigating it, if you have the repositories or you are a contributor to that, you are really interested in finding which commit caused that changing behavior. So that information, even if you are not an expert on that part of the tool, you can understand a little bit more about what's happening. Then the process in which you can use like a methodology to do that. And one of the ways you can do is try to investigate like the previous versions and try to find out this exact version in which the thing was working and then stopped working. One problem with that is that in projects like LLVM Clang, in which we can have more than 100 commits a day, it's like very time consuming. And for that reason, many tools, as it's a very routine and repetitive process, there are many tools that can help us to achieve this. A little bit of theory then. So the code bisection is this process of looking backwards on a given repository, trying to find a change in behavior, a specific change in behavior. Can be crashes, can be performance regressions. And you might as well be looking for when something was fixed, so it was not working, and now it is working. And I'm interested to know who fixed it, or if the fix was a side effect of another change. In order to run bisect, or any bisecting process, you need basically two things. The first one is to have a repository in which you have a relationship of the relationship with changes. So there was this original change, then there was this subsequent change, and then this one and this one on a timeline fashion. And also we need some test case or some way to label these given versions as this is a bad version or this is a good version. So as you have changes happening over time, you basically are interested to see, so on the latest one, so basically something that's not working, then you go backwards and you go backwards and until you find somebody or some version that in which the thing was working, then you can restrict your search space to that region and then you rerun the process until you will find the very specific version in which you have that thing working. Usually, when talking about source code, we are looking for a specific commit, and commit is tightly connected to source control. So it's natural that source control offers some sort of bisecting. Then Git, SVN, Mercurial, and others, they offer a bisecting option. It's good because you have all the information that you are looking for on that repository, so you can run bisection and look for very specific changes. You can also, so the source control, it doesn't know what is the expected behavior for that code. It's just a repository. But this gives you full flexibility to build that code if needed in a very customized way to fit your needs. On the flip side, you need to rebuild it, and you need to tell it, so this is the specific way I want to build. And this can make things a little bit difficult when you want to share this information with other people, because you have all your local environment and the influences of your local environment when doing this. Also, not all versions are able to build. So if you look for some, let's say, out of 100 changes on the compiler, you have some of these versions that are not possible to build because they are broken versions. Then, as I said, you need to set up the whole thing. You need to build it. You need to run your things. If you want to have a clean build each time, you need to set it up and clean up things as you need. And in big projects, it can be very time-consuming. When you have a big code base that takes a little bit long, more than a few minutes to build, and a lot of changes. So your search space is actually very big. Then, as we have a big code base and lots of commits, there is the need, or there was a need to have a specialized tool in order to run bisection on Clang and LLVM. And this was created 3 years ago. And this tool is llvmlab bisect. So using this tool, you have a specific environments to triage or bisect bugs or regressions in general on LLVM and Clang code base. So as I said, so this tool was contributed by Chris Matthews and Daniel 3 years ago. They are both at Apple. This tool is written in Python and is a specialized tool to bisect Clang and LLVM. There is documentation on GitHub you can find. The documentation is very comprehensive. In order to install it is a Python package. I recommend you use a virtual environment. Then it's basically those steps in blue. So you clone, you install, and you have it. So I didn't say it before, but I'm running a few demos during the talk, and my demos are running on a Raspberry Pi. So we can actually run this tool. This tool is completely supported by any Python 2 or 3 environment that you may have. So let me find the first thing. So Control BW. Yeah, this one. So I already installed this on a virtual environment, and following that steps. So I have one virtual environment in directory V. So I will source that thing, bin activate, and then I will have llvmlab, and then I will have the whole tool already running. So as I said, this is my Raspberry Pi. It's an ARM v7 running Linux, and that's as simple as that. So yeah, so installation. Basic usage for llvmlab, you need basically one thing. You need one test case to reproduce the failure you are investigating. So when you call this, you call llvm bisect, and then you provide the test case. I'll show you how to do that. But when you run any test case, so no matter what test case you are running or options that you provide, you will basically do 4 things. One, it will download builds from build cache. I'll tell you more about that in a moment. It will create a sandbox with that version. It will run the test case, and then it will navigate through the repository doing that process that I showed before with the timeline, labeling versions, and finding the specific commit we want. A few concepts that are involved. The first one, and one of the most important for the sake of llvmlab bisect, and is the main argument for using that, is saving time by using it. So the build cache is a cache full of pre-built packages with the toolchain. So basically, CI systems, so continuous integration systems, are Jenkins and BuildBot generate these packages. There are many types of packages that you can use out of the box, like x86 packages on v7 and AR64. They are stored on Google Cloud Storage, so you can download them. And then this is something that we did recently. We added support for ARM-v7 and AR64 like 3 months ago. And then these packages are being populated very often. So I'll show you how we do that. So for every commit that you do that goes to the main repository, we will have a buildbot server, so the upstream buildbot will keep polling the SVN repository each 2 minutes. And then if it sees some changes on either Clang, llvm, libraries, and a few repositories, we'll trigger builds on native ARM builders. So there are other x86 builders that are not maintained by us. These are the ones that we, as infrastructure team at ARM, maintain. So there is one native AR32 and one AR64 builder that will upload the binaries and packages for Google Cloud Storage that will be available. So as I said, this works very often. So each 2 minutes it polls the repository. And it's important for us to have these packages being created quite quickly. So we got 2 very beefy AR machines or ARM machines. And then we can complete this process and have, from a given commit to the build cache, you have them in 16 minutes, more or less. This is the buildbot job that is live and upstream. So you have also the configurations for what this job does on Zorg, which is a repository for infrastructure code and builds and automation within llvm. Then you have all these builds. You'll see many of these builds every day to have as many versions as possible to narrow down the resolution of the results of the bisection process. So you have very specific commits as much as possible. So when running bisection processes using llvmlab, you need to pick a repository in which the tool will use to download builds. So there are many. If you don't say any repository, it will use one x86 repository and download things to run locally. There are 2 of them that we are interested in this talk, which are these 2 ones. So Clang AR64 and ARMv7, which are the ones that we are publishing things. In order to pick a specific repository, we want to tell an option -b and point to the specific repository with these ones. I'll show you that.
What are the CMake ones? Are those the old ones that we were doing before?
Probably.
You probably can
Yes.
those things in.
Yes, so we only have rights to publish things. That's why we didn't remove anything or we didn't criticize anything. But we say llvm vmlab ls. So it's pretty fast, and you can have the production ones. There are no restrictions. If you install the command line tools, you have access to the whole thing. So there is nothing difficult or that you need to ask permission for. Then there is the other important thing is the sandbox. So the sandbox is the temporary location in which for every time you download a given version, you have this directory with the whole toolchain. So you'll be able to just, with the time that you need to download and extract this package, that's the time you need setting up your test environment. This is important to say. By default, sandboxes are deleted after the end of the process, but you can save them by providing -s and then providing a directory. By default, they go to /temp and they get deleted. Which sometimes, if you are like trying out your bug reproducer, it can be like a waste of time if it takes like 10 minutes to run the whole thing. You can save time by providing a custom sandbox directory. The other important bit that I'll go quickly is the predicates. So these are basically the command lines that you run to reproduce the behavior you are looking for. So you can, by the simplest usage, you have llvmlab bisect, and then you say, this line fails. Find me where this was working before, if any, right? So you can have a very simple command line that will trigger different versions and navigate through this repository, and then it will give you the revisions that you are looking for. So as you can see, there is something that's quite different here, which is this bit, the %path string. And this is basically, it will be substituted by or replaced by any version that you are trying out. So it will get that specific version path, then it will run the Clang from that sandbox. So it will get replaced by the tool, so you can test many versions. And also, there is not only the variable path, so there are many other variables that you can use to implement your test cases. You can also use all your previous knowledge on shell and pipes and output into files, graphing, and all your previous knowledge can be used to help you. And this is very useful when you are trying to troubleshoot something. So you can use it in two ways. One is via the command line, that you use the Python printf syntax, which is that one. You can also have it run as a shell script, and in that way, when calling the shell script, I will show it, you will get these variables injected, so these for the whole list that I showed before. So this is how you call it on command lines, just inline, or you can say run this shell script, and the shell script will have the variables in that format. You can also, so that variables are, when you are running the test, you get those variables. After you finish the test, you can also use test filters, so you can see for that specific test case whether the test passed or failed. You get a result on a variable called result, and you can also have the time measurements, as in user time, system time, and wall time. So this is the way you can use it. So you can say, for that given test case, if it passed and user time was less than half a second, then you use that expression to evaluate whether this test case was passing or not. This is useful when you are running benchmarks. So if you are trying to see why a given benchmark regressed or something, you can compile that benchmark with that version of the toolchain and then run it. So you can just do a command, semicolon, run it, and then you get these results as an output. There are other useful command lines, if you like. So there is variables reuse sandbox, which saves time by keeping the sandboxes, the temporary sandboxes, so you can reuse them. So this is something that we are upstreaming as part of the preparation of this talk. So I was trying so many bisections, and they were taking long. So I externalized this option as part of this. So you can restrict versions, so you can make the bisection process to run faster. So I have a couple demonstrations. I think I'll show one of them, and then you have the slides and you can reproduce the other. So the first one is an actual bug open on Clang. So Clang crashes when calling a function while both omitting a parameter and misspelling a parameter. So I can show you that one. So Control B, W, demo 1, cut, test.c. So when you provide this, you have the parameter as is unused, and another thing which is non-existent, toolchain will crash. Then the way to reproduce it, let me show you. Cut stars.sh. So this is basically the way I am running it. Oh, I have this command line in a better format. So this is the way I'm running this bisection process. So I'm calling llvm bisect. I'm calling reuse sandbox. So it won't download things and extract things on my local machine. It's just to speed up the process for demonstration purposes. I set a given max revision that I have previously downloaded, custom sandbox, and this is the reproducer. So I'm calling a shell, work length is this thing. I got all this information on the bug report. And then what I want to find to say that a given version is working, I want to get an undeclared identifier rather than a crash. So let me show you this thing. Oh. What is it? So this is the bug report. So what it does, it basically will crash the whole toolchain. And what we are looking for is a undeclared identifier. So I will just run this thing. And you will see that it will start, well, it's not very useful, but you'll see many fails, and you'll see a few passes. So it is limiting the search space. So it is failing until it passes. Then, OK, it reruns the process on that space as well. So in the end, it will say that Clang revision this number, this timestamp, is the first working build, and this one, this timestamp, is the next failing build. So it was working in this revision, and it was not working anymore on this revision. So that's the output you get for anything that you want to troubleshoot. So,
yeah, it should be the last working build, yeah.
Yeah.
Yeah, not the first working build. But that's just a message.
Oh, okay, yeah, but I think the first working build, it's seen from latest to oldest. So it's the first working build from in the opposite direction, and not the last one from the source, I guess. That's the meaning of the message.
The version was 3 less.
Well, yeah, but this is because it polls the repository each 2 minutes, so we can get a smaller resolution than one single commit.
It pulls from the wrong side. It's
Yeah.
the last. Yeah, okay.
Yeah. Okay, so yeah, I just need one more minute, just to a few discussions. So there is, just to summarize the gains that we will have on time spent on bisection. If we, that demonstration I did, I have already cached the download, the versions, and I have already extracted that versions. So it runs really artificially quick because I have everything pre-cached. In the real world, on a Raspberry Pi, it will take around 3 minutes to uncompress. That's the most time is spent on that thing. I have a few suggestions on how to fix that in the future, but still 3 minutes is not so bad. And if we do that in real world, we will have 1 hour and 10 minutes to test 23 toolchains times 3 minutes each, more or less. But on the other side, comparing this with the time we usually spend on creating the build cache items, which is more or less 10 minutes, to do the same process, we will have almost 4 hours to run the whole thing, considering we get that specific versions that we know that are possible to build, and we run the same, like jumping through versions to optimize the process. So this is basically 2 hours and 40 minutes that you get, more or less, in this comparison. Also that we are always having versions that will build and will work.
Yeah, Andrew, so the 10-minute build time, that's on because I happen to know that's on the 64-core pretty high-end server.
Yes.
It's on your Raspberry Pi, probably this would be, I guess, more than 24 hours.
Oh yeah.
Maybe 3 hours to turn it to more than 24 hours.
Yeah, that's probably more. I'm just not considering that we are building on a Raspberry Pi, because that would be like crazy. Yeah. So yeah, so that's the thing. We are building on a very high-end machine. I will tell you a little bit about that machine. And then still, if we compare Raspberry Pi versus Raspberry Pi, then it will be like days versus hours, right? To have all those versions. And I'm talking about 10 minutes because we are building from scratch. This is not an incremental build. So this is a very high-end machine. So this is the demonstration number 2. I'll just skip that. So as final remarks, so automated bisecting is a valuable tool to have on your toolbox to troubleshoot things on the tool chain. We can save time by using llvmlab bisect, as we just saw. And we recently added ARMv7 and AR64. So there is also this move within the LLVM community to move from SVN to Git. And then this will impact tools like that rely on revision versions. So I sent a message to Chris Matthews a few weeks ago, and we are discussing about that, getting ideas. And
with the monorepo, that's not going to be a big deal.
Yeah.
It would be a huge deal if it was a multi-repo or whatever that was called before.
Yeah.
Yeah, monorepo is actually probably simpler because you can use git bisect.
Yes. Yeah, and also we don't really need to track the revision number versions to trust that in this scenario. We can just get the continuous integration tool build ID or something that is shared and known. So these machines that we've got for the LLVM project, these machines are actually free, and each and every open source project can request some of them. This is an initiative called Works on ARM, which offers machines or remote machines that you can use. So very powerful machines to try your continuous integration jobs and see they working and supported on ARM in general. This is the URL. You can request resources, opening basically a GitHub issue. All instructions are on that website. And we use it, and these machines are very reliable. We have them running for months without any problem. Yeah.
We have those machines as well, and they're extremely reliable.
Yeah. So we use them, 2 machines. One is a ThunderX2, and one is a ThunderX1. And the other one is another high-end machine.
High 1660.
Yeah, this one. Yeah. Yeah, and that's it for me. Thank you. Thank you. And if you have any questions, I'm happy to answer them. Yeah.
Do you have any tips for taking an LLVM lit test case and then running? Because that's usually what I have to do. Like I have a test case that's failed, and I'm not exactly sure when it failed. So I'm guessing with this, it looks like you need to manually extract like the test case out of the LLVM lit test case, put it in a shell script, and then pass it to this.
But it has the run line, right?
It has the run. What I mean, you can like the way I guess I would do it is that when LLVM lit runs, if you have it set to the external shell mode, it actually spits out a bash script, and then I guess you would just need to change like the hard-coded path to what.
Yeah. So the question is about the test cases in which you have tools like file check and not those things, right? Yeah, I don't really know, and I didn't test with any of them, but yeah, I think you can find a way. If you have a bash script out of it, you can reproduce the thing very quickly. Yeah, and then you probably just need to change the places in which you need clang to have that path variable on it, and that's it, basically. Yeah.
So one possible feature enhancement here is that I'm guessing if you want to, at the moment, do x86, you need the x86 machines, you've got the ARM machines, and you can only do what you've got your native build cache, but not everyone has that. But I imagine it could be possible for a lot of tools to basically use QEMU. So if you kind of have an option to integrate an emulator where you kind of say, run this test, but run it under an emulator, and then you could affect anyone with an x86 machine could plug an ARM program.
So yeah, so the first thing on this way, so from the ARM machine or from the x86 machine run something on a QEMU, this is kind of already supported because you can have a bash script, and if you can do that on a bash script, you can do that on this.
Just be documentation.
Probably, Yeah, and there is also a curiosity on this, is that we build also the backend for x86. So you can use, on your ARM machine, you can generate the x86 binaries, and even if you have a way to run them, you can do that as well.
We're
Yeah?
out of time. We're out of time. Thank you again.
Yeah, thanks very much.